Hey guys, this is 5.5. We are finding the greatest common factor, which we also call GCF, okay? We're practicing how to find the greatest common factor so that you can factor by grouping. So those are the two things we're going to practice today. A factor, or factors are numbers we can multiply together to get another number. So 2 times 6 is 12, means that 2 and 6 are factors. We say factors of 12, okay? So today we are talking about the greatest common factor. Hold on. All right, the greatest common factor we also call the GCF, okay? The greatest common factor is the largest of the factors of all the integers. Integer is a number, or polynomial. Polynomial is a number and a letter involved, okay? Finding the GCF of a list of monomials. So first, we want to find the greatest common factor of the numerical coefficients. This just means of the numbers. Okay, and then we find the greatest common factor of the variable factors. Here we mean the letters. The product means multiply, right? The product of the factors from step 1 and step 2 is the GCF of the monomial, okay? If there are no common prime factors, the greatest common factor is 1, and we can call that number a prime number. A prime number means the only factors are 1 and itself. The number 3 is a prime because the only factors of 3 are 1 and 3. So, let's do an example. Let's do the number 12. So for 12, let's list the factors. What numbers can I divide 12 by and get a whole number? 12 divided by 1 is 1. Sorry, 12 divided by 1 is 12, right? 12 divided by 2 is 6. 12 divided by 3 is 4. So I can write 4 too. 12 divided by 4 is 3. 12 divided by 6 is 2. And 12 divided by itself is 1. So those are the factors of 12. Okay. To find a common factor, I need 2 numbers or more. So I'll do 30. You can divide 30 by 1. You can divide 30 by 2. You can divide 30 by 3. I don't think you can divide it by 4. You can divide it by 5. You can divide it by 6. You can divide it by 10. 30 divided by 15 is 2. And then 30 divided by itself is 1. So these are all the factors, okay? Here are the factors in purple. All the factors of 12 and 30. Then I'm going to narrow it down and I'm going to say 1, 2, 3, and 6 are the common factors. So the common factors of 12 and 30 are 1, 2, 3, and 6. Okay, and then one more, the greatest common factor. or the GCF, is whichever common factor is the biggest. The GCF is 6 for these two numbers. We found all the factors. We found the biggest of the factors that they both have. That is the greatest common factor. All right, ready to practice this? All right, example 1. Find the greatest common factor of each. Sorry, I'm moving this around so much. Really need to get settled. Put that like that. Find the greatest common factor of each list of numbers, okay? So, $12 and 8. What are all the factors of 12? I can divide 12 by 1. I can divide 12 by 2, 3. If I divide 12 by 3, I get 4. If I divide 12 by 2, I get 6. And if I divide 12 by 1, I get 12. So those are all my factors of 12. And then I have the number 8, okay? I can divide 8 by 1. I can divide 8 by 2, and I get 4. And then if I divide 8 by 1, I get 8. So those are all the factors of 8. The common factors are 1, 2, and 4, okay? The greatest common factor is going to be 4. 7 and 20. 7 is like 3, we call it a prime. It only can be divided by 1 and itself. So you can tell the difference between 1 and 7, put a line through the 7. So 7 is prime, we call it. So I think you can see that it does not matter how many factors 20 has, right? 7 only has 2. So 20 we can divide by 1, we can divide it by 2, we can divide it by 4. If we divide it by 4, we get 5. If we divide it by 2, we get 10. And if we divide it by 1, we get 20. So those are the factors of 20, but the only common factor is 1. Okay. Letters are a little bit different. So letters, you're going to want to think back to the 5.1, the rules of exponents, right? So for 5.1, we said that if m and n are integers and a is a real number, then to multiply, we add those numbers together, right? We said to divide, we subtract those numbers, right? Okay, so I want you to think about the exponent number right here as something that you are multiplying together, right? We multiplied 3 x's to get x to the 3rd. We multiplied 7 x's to get x to the 7th, right? And just like over here, 2 times 6 makes 12. Here, x times x times x makes x to the 3rd, okay? So here we have x to the 3rd is just x times x times x. X to the 7th is x 7 times. Okay? So, and remember, when we're multiplying, we're adding. When we're dividing, we're subtracting. Okay? And the reason we are finding the greatest common factor is so that we can divide. Okay? I can divide 12 by 4. If I divide 12 by 4, so if I divide 12 by 4, I get the number 3, right? If I divide 8 by 4, I get the number 2. Okay, that's why we're finding the greatest common factor, is so we can make these simpler. So What can I divide x to the third and x to the seventh by that makes it simpler? What's the biggest number? It's 3 x's, right? So x to the third and x to the seventh, the greatest common factor is x to the third. And just like 12 and 8 will become 3 and 2, let's just pretend, okay? Let's pretend we're saying that this is 12 plus 8, and I want to simplify it by dividing by 4. So now I'm going to say it's 4, and instead of 12, 12 divided by 4 is 3. And then 8 divided by 4 is 2, okay? Here, we have x to the third and x to the seventh. I'm going to divide out the x to the third, just like I divided out the 4. So I just get a 1 here, right? And here I get 7 minus 3 is x to the 4. Okay? So it looks pretty different when you're doing numbers and when you're doing exponents of variables, but it's the same thing. You're dividing out something, okay? And we're going to practice this a lot today, so it will become clearer if it's not clear to you. Here we have 6x to the fifth and 4x to the third. And remember, it says if you have a monomial with numbers and letters, first find the greatest common factor of the numerical part, the numbers, then find the greatest common factor of the letters, the variable part, all right? 6 and 4. All the factors of 6, 6 can be divided by 1, 2, 3, and 6, right? 4 can be divided by 1, 2, and 4. So our greatest common factor is 2. Okay, x to the third and x to the fifth. Yeah, so that's 3 x's. That's 5 x's. But what you can really just look at is 3 and 5. What's the biggest number? Sorry, what's the biggest number both of them have? It's 3, right? So I would say it's 2. X to the third is the greatest common factor, the biggest number of x's you can put as a common to both of them. 3 is common here and here. 5 is true here, but 5 is not true here, so we can only go up to 3. All right, so let's practice it with AB, this AB guy. I'm giving 2 colors. All right. A to the third, the second, and the fourth. Remember, you can only take the biggest, the smallest number, basically, right? This one has 3, this one only has 2, this one has 4. So I can only take the 2. And then when we look at B, we have a squared, a fifth, and a seventh. We have to take the smallest one, B squared, okay? So the greatest common factor of the 3 of these is A squared, B squared. The greatest common factor of these 2 is 2x to the third. All right, and we can pretend like we're taking it out of these. So 2x to the third, and it used to be 6x to the fifth plus 4x to the third, right? Now 6x to the fifth divided by 2x to the third, 6 divided by 2 is 3. X to the fifth divided by x to the third is x squared, right? 4 divided by 2 is 2. X to the third divided by x to the third is just 1, right? Here we have a squared, b squared. This one will become a, right? This one will become b to the third. And this one will become a squared b to the 5th. All right, if we were using them to factor the polynomial. If the polynomial was first an addition problem and we wanted to factor it. Okay, so for factoring polynomials, the first step is to find the greatest common factor. Then we will write the polynomial as a product by factoring out the greatest common factor from all the terms. So here we have 9x is one of the terms and 3. So this is just like up here, but instead of the and, we have a plus, okay? 12 and 8, it was 4. 9x and 3, let's start with just the numbers, right? So the numbers are 9. 9 will be 1, 3, and 9. 3 is prime, so 3 is just 1 and 3. So the common factor is 3. The greatest common factor is 3, okay? And then there's 1x here and there's no x here. So the greatest number of x's is 0 x's. So the greatest common factor is simply 3. Now it says factor out 3. Divide 3 from each one. Take 3 from 9x, take 3 from 3. Tell me what you get. 9x divided by 3 is 3x. 3 divided by 3 is 1. You're done. Okay, and if you redo that, if you go back and you say 3 times 3 is 9x, sorry, 3 times 3x is 9x, 3 times 1 is 3, you get your original polynomial. So you can check it. We factored out the greatest common factor and then we checked it. So let's work some examples. Factor out the greatest common factor in each of the following polynomials. Okay, so basically these are all in standard form. And you are changing them to factored form. Darn it. Wish you had seen that while I was writing it. Okay, so the greatest common factor for 6x to the 3rd minus 9x squared plus 12x. Remember, we start with the number. So the number here is 6, 9, and 12. You might be faster than me, you might already know. 6, we can divide 1, 2, 6 divided by 2 is 3, 1 divided by 6 is 6, right? 9, we can do 1, 3, and 9. 12, we can do 1, 2, 3, 4, and 12, right? So the greatest of these, well, what's in common? We have 1, we have 3. So 3 is our greatest common factor for the what's the word they used? For the numerical coefficients. The numerical coefficients, it's 3. And then for the variable factors, we have x to the 3rd, x squared, and x. What's the biggest exponent we have? The biggest exponent is just 1, so we have to say it's 1. X to the 1st power. Okay, so that is our greatest common factor. Now we're going to factor it out. This means 3 times what will get me, 3x times what will get me 6x cubed, right? 3 times 2 will get me 6. X times x squared will get me x cubed, right? Negative 9x squared divided by 3. Negative 9 divided by 3. Nope, Negative 9 divided by 3 is negative 3. Remember, for exponents, we subtract. So x squared divided by x is just x. And then now you have a positive 12. Positive 12 divided by 3 is 4. And then the x divided by the x leaves you with just 1, right? X divided by x is 1. 1 times 4 is 4, so I can just leave it as a 4. All right. 14 x cubed y plus 7 x squared y minus 7xy. So 14, 7, and negative 7. Make sure we recognize that that's a negative. It's probably 7, right? Because 14, you can divide it by 7. 7, you can divide it by 7. So let's call the numerical coefficient 7. And then we have two different variable factors, x and y. The biggest x is just x to the first, and the biggest y is just y to the first as well. So our greatest common factor is 7xy. 14 divided by 7 is 2. X to the third divided by x is x squared. Y divided by y is 1. I don't need to write the 1 because 2 times 1 is 1, right? 7 divided by 7 is 1. So it's a positive. 7 divided by 7 is 1. Just like the y, I don't need to write it. I can if I want, but I don't need to. X squared divided by x is x. Y divided by y is 1 again. I don't need to write it. Now we have a negative 7xy divided by 7xy. Negative 7 divided by 7 is 1. X divided by x is 1. Y divided by y is 1. When they're all 1s and there's nothing else I'm about to write here, I do need to write the 1. Because without the 1, if I tried to multiply it out, it would not give me the correct answer. So let me show you. So 7xy times 2x squared would give us 14x to the third y. 7xy times x gives us 7x squared y. 7xy times negative 1 gives us minus 7xy. If I had just said instead 7xy 2x squared plus x, and then I didn't write the 1, I would not have a way to write this last piece, right? I couldn't include this last piece in my multiplication. It would just be 14x to the third y plus 7x squared y. So you need the 1 if the 1's alone. If the 1's not alone, you don't really need it. Okay. Here are some parentheses. You might be thinking, I need to clear these parentheses. But do you see how they are exactly the same parentheses? X plus 2. X plus 2. So they are actually a common factor. Yeah? 6x squared, for 6x squared, the 6 is a factor and the x squared is a factor because they're multiplied together, right? Here, sorry, 6x cubed, the 6 is a factor and the x cubed is a factor because they're multiplied together. Down here we have a 6 is a factor and the whole quantity in parentheses x plus 2 is a factor. I can factor out the x plus 2, yeah, because the common factor is the x plus 2. So we're doing the distributive property in reverse, okay? So I'm going to take out the x plus 2, just like I took out the 3x. And then what I have left is the 6 minus y. And I'm done. Okay, this is one term. This is now one term. All right, same over here. We have y plus 1, y plus 1, one term and one term. So I'm going to take out the y plus 1. And I'm going to multiply it by what is left. X, y minus, this is an understood 1. So I need the 1 there so that I can get the right answer. Okay. We have factored out x plus 2 because if I go back through, 6 times x plus 2 gets me 6x plus 2, and negative y times x plus 2 gives me negative y x plus 2. So now we're going to use this to factor by grouping. We group the terms. It's for 4 terms if you look at your next slide. Factoring by grouping is for 4 terms when you don't see anything in common, okay? Instead, we're going to group the terms into 2 groups. So instead of 4, instead of 2x plus 3x plus 4y plus 5y, instead of 4 terms, I'm going to put them into groups of 2. 1, 2, okay? And then each group I will see if it has a common factor and take that out, okay? Factor out the greatest common factor from each group. And if there is a common binomial factor, factor it out. If not, rearrange the terms and try these steps again, okay? Here, the common factor would be x, right? And here, the common factor would be y. So let's practice. I guess I can finish this. So 2x plus 3x, that becomes x, 2 plus 3. 4y and 5y becomes plus y is the only thing I can factor out. 4 plus 5. Okay. Let's practice. In this example, we have 4 terms. Do you see anything common to all 4 terms? We have an x, a y, we have an x here and an x here. We have a y here and a y here. We have a 5, a 3, and a 15, but no number here. So we don't have anything common to all 4, but if we group 2 together, we might be able to see something to factor out. So I'll just take the first 2 and then the second 2, because that's the easiest way for me. All right, if I just look at xy minus 5y, I can factor something out, right? xy and 5y, the only thing in common is a y. If I take out the y, I'll have an x minus 5. Now let me look at the other side. The other side says plus 3x minus 15. I want you to always keep that sign. You have to always keep that sign out front. So whatever you're factoring out must have the sign in the middle. So this will be positive, positive, and positive second term. 3x and negative 15, what do they have in common? Three has 1 and 3. 15 has 1, 3, 5, and 15, right? So their greatest common factor is 3. 3x divided by 3 just gives me x. Negative 15 divided by 3 gives me negative 5. So I have found a common factor for these two and a common factor for these two. I took out the common factor and I ended up with something that looks a lot like this one, right? It looks just like this, but I found it myself because they both have x minus 5, right? Those are exactly the same. So that's what we're going to now factor out of this pair. So I'm going to say x minus 5. And what I am left with is y plus 3, okay? And you see how there's no sign between them? They're just being multiplied, okay? Okay, so 15x to the third minus 10x squared plus 6x minus 4. Look for a greatest common factor. There is not a greatest common factor. Separate them into two groups, all right? Our first group is 15x squared minus 15x to the third minus 10x squared. $15 and 10, 5, right? X to the third and x squared, we can say it's x squared. 15x to the third divided by 5x squared will give me 3. X to the third, x squared will give me 1x. Minus 10, negative 10 divided by 5 is a negative 2. X squared divided by x squared is just a 1. Now I'm going to go on to these two. Remember, I'm always keeping it positive, so I just put a plus right here. It's going to be a positive number. 6 and 4. 6 has 1, 2, 3, and 6. 4 just has 1, 2, and 4, right? Greatest common factor is 2, x and no x, so it's just 2. 6x divided by 2 is 3x. Negative 4 divided by 2 is negative 2. Now when we look, they both have 3x minus 2. So I can factor out 3x minus 2. I am left with multiplied by 5x squared plus 2. Okay. You see anything in common here? No, right? Nothing is common to all four. And you might be thinking, oh, if those two were next to each other, it might be easier. And you might want to flip those, and that's okay. If you feel like you want to flip those, you can. I'm not going to flip them. So I have 5a squared plus, 2a squared plus 5ab. The only thing in common is 1a, right? So I have a. 2a squared divided by a is just 2a. 5ab becomes positive 5b when I take out the a, right? On the other side, I have to keep that plus. Oh no, there's nothing to factor out here except a 1. I guess I'll just try 1. And then I'll write everything the same. 2a plus 5b. Now I will look at what I got. And I will see that these are still the same, so I can still use them, okay? So it's still just 2a plus 5b times a plus 1. Oops, wrong color. Okay. And I do want to show you in case if you had, yeah, like I want to put the twos together. It makes more sense, right? If that's you, I'll show you what you end up with. You're not wrong. So I'm going to move these around. I'm going to say 2a squared plus 2a plus 5ab plus 5b, okay? Because that looks better to me. So now I have 2a squared plus 2a. I can factor that out into 2a. So all I have on top now here is a, right? 2a squared divided by 2a is a. And then 2a divided by 2a is just plus 1. Plus 5ab plus 5b. So I'm going to say plus 5 and 5. I can say 5a, no, b. Plus 5b. 5ab divided by 5b is just a. 5b divided by 5b is just 1. Okay. That's still the same. So I can factor out a plus 1. And my other quantity will be 2a plus 5b. So even if you want to move it around, you'll still end up with the same answer, okay? As long as your factoring is correct. Example 5, we have x to the third, 4x, x squared, and 4. Is there anything common to all 4? I can move them around, or I can just take the first two. X to the third plus 4x. The only common factor is x. X to the third divided by x is x squared. 4x divided by x is a positive 4. Okay. Now I have plus x squared and 4. That's just a 1, but that worked last time, so I'm going to use it. X squared plus 4. I see that these are the same, so I can factor them out. X squared plus 4, and I'm left with x plus 1. Okay. Here we have 3xy plus 2 minus 3x minus 2y. 3xy plus 2, nothing. Negative 3x minus 2y, nothing. Let's see if I move it around, okay? I'm gonna move it around to 3xy minus 3x plus 2 plus 2y. That looks a little bit better. All right, 3xy minus 3x. I can factor out a 3x. 3xy divided by 3x just gives me y. Negative 3x divided by 3x gives me minus 1. See that? Okay. Plus 2 plus 2y, so I need to add. The only thing I can factor is a 2. So now I have a 1 because 2 divided by 2 is 1. 2y divided by 2 is y. So I found something. I found a way to group them and find a factor, but I see that this and this do not match. These do not match, so I cannot pull them out as a common factor, right? So if you cannot find anything in common, even a binomial, we call it prime, just like we were calling the number 3 prime, because you can only divide it by itself and 0. Okay, this you can only divide by itself and 0. It is prime. And that is that was our last example. Thank you very much. Today you learned how to determine the greatest common factor, how to pull out the greatest common factor, whether it's a number, a variable, or a combination of both. Okay, you found a way to factor 4 unlike terms by grouping them into groups of 2 and then finding a common factor for just those 2. And if that common factor is also common to these 2, then you can put them back together, right? And then you also learned that that middle sign has to stick with that second term. Okay, that is what we learned today. Thank you so much, and I'll see you next time.